LG began to take off. Just a minute, guys. So in 2000, LG announced their first smart refrigerator, and then in 2008, it is important to note that there was first international conference. Along with that, the number of connected devices exceeded the number of people on the planet. And then in 2009, Google started testing their driverless cars. Further, IoT has developed so much, and we'll be seeing the current trends in further slides. So, so this is the basic working of IoT, which includes four key components or four key stages, I can say. That is sensors capturing the data. So can anyone give me an example of what data can be captured or what sensors can be used?
Maybe photolytic sensors like capturing the brightness of an object.
Yeah, that is one good example.
Thermal
Anything else?
sensors. Thermal sensors.
Yeah, fine. So I assume you all have a basic idea about sensors and how they work, right?
Yeah.
Yeah, fine. So when I say capturing the data, it can be as simple as temperature, or it can be as complicated as real-time video feed. And coming to sharing of data, so with the available network connections, IoT devices can share the data to either public or private clouds, or they can also share within themselves. That would be an device-to-device communication, or they can also store it locally for processing at their ends. And coming to processing the data, so at this point, software is programmed to do something based on the given situation. Would anyone give an example of that? Processing the data and doing the edge computing there itself.
Autofocus.
Okay. Any other examples? It can be as
Question again.
Yeah, when I say processing the data and using the softwares to do something based on a given situation. Example for that?
In a voice recognition robot, it recognizes the command and acts on it.
Okay. So it can also be as simple as sending a trigger or a warning message at the edge. And coming to act on data, it's nothing but accumulating the data from all the devices within the IoT network and using it for analysis, and it would deliver powerful insights, or it can say like if the better actions can be taken. So next, coming to key concepts of IoT hardware, as you all know, the heart of IoT is nothing but billions of interconnected devices with attached sensors and actuators that sense and control the physical world. And coming to embedded programming, it's nothing but IoT devices are embedded devices, and they may be prototyped using microcontroller platforms such as Arduino, and then in the later stages being transformed into PCBs. Coming to networking and cloud infrastructure, so a network design is essential within IoT due to a huge or bulk volume of connected devices and the heterogeneous type of data all of these devices produce. So the impact of network design also matters at a scale. So Coming to data analytics part, so all these IoT devices produce a bulk amount of data, and they can be used for getting better analytics, and it can also be used as data sets for prediction models and stuff. And then coming to security, one of the most critical concerns in IoT and which is closely related to data ethics and privacy is security. So it must be built at every step of the design. So coming to examples, can anyone give an example of environmental data gathering?
Humidity sensors.
Yeah, that is one good example. It can be temperature, humidity, or carbon dioxide levels, hazardous gases levels, anything like that. Basically, just sensing your environment. There are many air quality sensing things and stuff. Coming to smart homes, I'm sure all of you would have at least one or two IoT devices at your home. Could anyone name few?
Smart light, smart fans.
Yeah, smart lights, smart fans. Other than that,
Alexa.
yeah, Alexa, that's what I was looking for. And healthcare systems, I'm sure all of you would have seen medication dispensers or smartwatches that help doctors to monitor the patients remotely. Ever since COVID, IoT in healthcare has increased a lot. That is one thing you guys can read upon more and stuff. And what about connected cars?
Tesla.
Yeah, okay. Can you name a specific one? I mean, not the car as a whole, one IoT aspect of it.
Self-driving.
Sorry?
Self-driving.
Yeah. In self driving, what IoT aspects can you see?
Detecting the vehicles and the barriers around it.
Yeah. All those data collected can help in further building of the models and stuff. So that is one example. So next we'll see the types of IoT protocols. The two major ones are IoT networks and then comes IoT data protocols. So IoT networks, I'm sure most of you are familiar with all of these. So while using networks in IoT, it is. 什么意思啊？ Yeah. So coming to networks in IoT, basically all these are application specific. So depending upon the data rates you want to transfer in or the approximate ranges, you can use a specific one where a Wi-Fi is best suited for LAN networks that interconnects computers in limited zone. Bluetooth is widely used in IoTs. I request you all to mute yourselves if you're not answering and stuff. Yeah. So Bluetooth is commonly used in short range applications, that is preferably personal products like wireless speakers. And one major advantage of Bluetooth is it reduces the power usage, and so it's very useful in IoT applications, specifically being a Bluetooth low energy thing. And coming to Zigbee, it is also wireless and low power consumption protocol. It is widely used in home automations, and devices usually communicate with each other using radio transceivers in this Zigbee. And LoRa is nothing but a long range. So this is also a low power protocol, and it's wide area networking protocol built on LoRa modulation scheme. So you can transmit up to long ranges using very less power. And cellular, it's obvious that if you want to send huge or bulk amount of data over long range, it's also a long connectivity range. Cellular networks can be used. So coming to IoT data protocols, first we'll see the REST API. What is API? Anyone?
Something that
Application programming interface.
Yeah, it is application programming interface. Any basic idea on that?
it fetches data.
It allows us to use some services provided by the API,
Yeah,
and like we can only borrow it. Like we can't. It's like only taking a part of the service, not the entire service.
right. So it's basically a piece of software, I can say, that allows them to communicate with each other. So REST API pretty much works like as a web server where you as a client can make a request to the server and get data back over a HTTP protocol, and we'll see the HTTP protocol methods further while we are using ThinkSpeak. And coming to WebSocket, does anyone have an idea on WebSocket or any examples on that? Anyone?
Basically every um, protocol will have its own WebSocket. In order to access it, we need to use that particular WebSocket. For example, HTTP will have one particular WebSocket
Mm-hmm.
through which we can access the application.
Yeah.
Maybe it is used to connect to the server or something.
Yeah. Does
I'm not
anyone know any
sure.
examples?
Like, is it used for like live communication between two devices?
Yes, yes. Yeah. So WebSocket is also like a client and server model, but it's bidirectional. That is, both the users can send messages at a time. The best example is your chat applications for the WebSocket. That is one basic thing, and further you can read upon this data protocols. So next is this.
But WebSocket also has a lot of disadvantage, right? Like it's not really used in IoT devices now because it really can't hold the signals. So
Yeah, so based on your
requirement is
requirement, you need to choose the particular data protocol and the network protocol.
okay.
So coming to MQTT, MQTT is nothing but message queue telemetry transport, and it works or is a it works basically on a messaging protocol called publish and subscribe that avoids direct connection between the devices by relaying the data through the central server called broker. So here is a basic example. Suppose, let's say, this temperature sensor publishes the temperature. So this is the publisher, and it publishes the temperature under the topic name temperature. Remember the topic name temperature to this MQTT broker, which stands between the publisher and the subscriber. And if these subscribers want the particular data, let's say temperature in this case, they have to subscribe to the topic temperature. Only then they can access the data which is under that topic. So that is the basic idea of this MQTT, which works on publish or subscribe based messaging protocol. So you'll also see this in ROS, where you have to subscribe to a topic and stuff. So other things are COAP, that is Constrained Application Protocol, and other things which you can read upon. These are the main data protocols which I wanted to mention. So device communication, I think it's pretty obvious. What is serial communication? Anyone?
Data is sent one after the other.
Sorry? Okay, I'll tell. So, communication is nothing but sending the data between um, two devices, I can say, using the transmission lines, wherein at a particular time only one bit of data is transmitted. Just a minute, I'm allowing few people. Yeah. So that is simple serial communication. Coming to SPI communication, that is serial peripheral interface, is nothing but communication between your microcontroller and any other peripherals. So this is synchronous and full duplex. What is full duplex communication? Does anyone know about that?
It's the live communication.
Simultaneous communication between both the
Yes,
sides.
that is full duplex communication. And as in SPI communication, the devices follow slave relationship where the master can issue the commands and the slaves can act accordingly. Coming to I2C communication, wherein here the communication is between the ICs on the same PCB, unlike microcontroller and peripheral in the SPI communication. This is also full duplex and synchronous. Here you can have multiple slaves and multiple masters based on how you want the communication to be. So, the current trends for IoT. Does anyone have an idea on how many connected devices are there at the moment? Approximately, at least.
Few trillion.
Not so much, yeah. So, currently, there are over 7 billion IoT devices installed throughout the world, and this number is expected to rise to over 30 billion by 2025. And coming to the trends which are given here, IoT data feeds AI models. Any idea on that?
Um, the IoT data helps AIs to train themselves.
Yeah, so IoT devices generate a lot of data, right? That is a good basis for data sets for AI models. So they can provide better insights. And yeah, that is about IoT feeds AI models. And there's something called Internet of Medical Things, which mainly focuses on healthcare, IoT in healthcare. That is one thing to read upon. And Industry 4.0. Anyone? What is Industry 4.0?
It's heavily automated.
Yeah, heavily automated. And so the vast improvements in manufacturing and industries brought by widespread of automation and increased efficiency. So in that, the major component is IoT, without which large scale collection of data and monitoring in the industrial capacity would be impossible. So Industry 4.0 is one. Coming to cybersecurity, as I told earlier, that security is one of the main concerns of IoT. So cybersecurity and data privacy are of serious concerns. And what about IoT transforms the global supply chain? Any example on that?
It closes the gap between supply and demand.
Yeah.
So it's easier to communicate where I can get other goods from.
Anything else?
Can be used in warehouse management.
Yeah, warehouse management, yes. So there are many other trends which you can read up on this blog, IoT trends. I'll be sharing all the materials later, so you can read up on that. So for today, we'll be using this hardware, that is ESP8266. This ESP8266 is a system on chip which is integrated with the TCP IP protocol stack, and it can provide any microcontroller access to any Wi-Fi networks. It has this 10 silica 32-bit RISC processor. This is the system on chip, while this is the development board that is built around the system on chip. So we'll be using this for today. You guys can use any other hardware if you have. That is either ESP32 or just Arduino with Wi-Fi Shield also works. So these are the few specifications. You just need a USB, micro USB cable to connect it with your laptop, and the operating voltages and other specifications here. It uses this specific Wi-Fi protocol, and these are the few images on pins. So this totally has only 17 GPIO pins, while ESP32 has even more GPIO pins. Yeah, and it has pulse width modulation scheme. I think uh, I hope everyone is familiar like how to work with Arduino and stuff.
Yes.
Yeah, fine. So this is a small comparison between ESP8266 and 32. So given a choice between these two, I recommend you all to choose ESP32 because it's more relatively new and more advanced, where the speed of the Wi-Fi is boosted with Bluetooth 4.2, which is not included in ESP8266. And even the GPIO pins, it's more in ESP32. So it'll be more useful. And even the microcontroller units, this is single core and this is dual core. So I recommend you guys to use this. Today we'll be using this ESP8266. So today we'll be working with these two IoT platforms. The first one being the ThinkSpeak. So this ThinkSpeak IoT platform is by MathWorks, and it is an IoT analytics service that allows you to aggregate, visualize, analyze the live data streams in the cloud. Because it's from MathWorks, you can very easily execute the MATLAB codes in the ThinkSpeak and have instant visualization of data. We'll have a hands-on session after the basic introduction on this. So this is basically the idea. So you have your microcontrollers equipped with sensors and stuff, which will be sending the data to the cloud where data aggregation and analytics is done. Um, yeah, that's the basic idea of this ThinkSpeak. Yeah, so now I'll stop sharing and we'll start off with the ThinkSpeak. So can you all open and sign up for ThinkSpeak account? Just type ThinkSpeak. Can you all see my screen?
Yeah.
Yeah, you all can do it side by side. You can ask if you have any doubts and stuff. So this is basically the ThinkSpeak platforms, and it has something called channels, where you can create different fields to upload the data from your sensors. We'll look in detail about that. Has everyone have this open and have signed up?
On it.
One second.
Yeah, yeah, fine, fine. You guys can let me know once majority of you y'all are done.
Done.
What about others?
Yeah, done. And by the way, I have
Done.
Yeah, fine.
by the way, I have a Raspberry Pi Pico W. Is it also fine for this thing?
Yeah, you can use any hardware. That doesn't matter.
Thanks.
Yeah. Okay. I'll start off with the platform. So once you're signed in, you can go to channels and then just click on public channels. So all these channels are public and which is created by someone else. So if you click on one particular channel and see, um, there'll be different fields of data. That's nothing but data uploaded by for different parameters, I can say. So this is temperature in their case, and this is humidity, I think. So there are different fields under one particular channel. So we'll be creating something like this today, for which you have to go to channels and then my channels. Is everyone with me?
Yeah.
Yeah.
Could
Once
you please repeat it again? Like you told us to click on one and we get several data after that.
uh, yeah, that's it. That's just to see what
Okay.
ThinkSpeak is all about. We'll be creating of our own now, for which you have to go to channels and then go to my channels.
Okay, okay, sure. Thank you.
Yeah. And here I already have 4 channels. That is the maximum limit of channels you can create without any subscriptions and stuff. So you guys can go to new channel and then create one of your own. Let me a new channel, clicking on this green
Yeah,
color
thank
thing.
you.
So once it is created and you click on it, it should look something like this. Is everyone able to do it?
Yeah.
Okay.
Excuse me.
Yeah.
Could you please repeat the whole process after you sign in and then to create choose channel
Yeah.
from that point on? Thank
Yeah,
you.
fine. So once you sign in and stuff, you'll have something like this, and then go to channels here, and then just click on. Oh, you'll not be having any channels, so just directly create a new channel.
Okay.
Yeah. For those of you who have already done, you can come to channel settings after clicking on your channels.
What do we give for name and description fields?
Anything, whatever you want. Fields, I'll tell you. Name and description is your choice. So here in ThinkSpeak platform, there are for each channel you'll be getting 8 fields. That is, you can upload, let's say, 8 parameters of data, each one corresponding to one particular parameter. So here you can enable as many as fields you want just by ticking this box, and you can name whatever the field name you want. For now, I have only this one field enabled, and it is temperature. Is anyone having any doubts or not able to do it or something like that? Okay, I assume not, and I'll continue. So once you have enabled a particular field and given a name to it, as you scroll down, you can see many other options such as the location, the tags, the short video and stuff. For now, we are not using that, and after that, you just have to save the channel. Click on the save channel.
Could you please repeat it again? Like just like the one which you told just like 2 seconds back.
Have you created the channel?
Yeah, everything is done. What
Yeah.
about the link and all the stuffs?
Which one?
The links and things like that. Links,
That
tags.
is only if you want to link your this thing ThinkSpeak channel to any other links. So for now, we'll not be using that, so it's fine. You
Okay,
just
and
have
then
to,
just click on save channel. Yeah.
click on save channel. Yeah.
Should we make any changes to the fields given, or it's okay if we have only one field?
You need to have at least one field enabled. We'll be uploading the temperature data, so I have that one field enabled.
Okay. Yeah.
Yeah. After saving the channel, if you come to the private view, you can see a widget like this, but you'll not be having any the red graph or something. You just have an empty graph. Is everyone able to get that?
Yes.
Yeah.
Yeah.
So now we'll see how to upload data to this particular widget. First, we'll see how to do it through browser, for which we'll need to understand a little about the API keys. So we'll be using the write API key and the read API keys to perform actions on those fields. So when you scroll down a little, you can see the API request region, and below that you have something called write a channel feed. Can you all see that? This particular part.
Yes, we can see.
Yeah. So what I want you to do is the URL which is there here, just copy paste that in your browsers. Is everyone able to do that?
Yes.
Yeah. What can you see?
Yes, yes. We just see one thing.
Like a text box
Yeah.
or something.
Okay, 1 second. Let me share my screen. I'll share that tab.
The value just got updated.
1 second. Yeah. So once you just you guys can see, right?
Yeah.
Yeah. So once you just enter that particular URL, it'll give you the number of entries you have uploaded for that whole channel. So suppose I'll come to my private view, and you can see that yeah, the value gets updated to 0. That is because here, so this is the right API key, and then field 1 is nothing but you are updating the value to field 1, and what you're updating is nothing but 0. You guys can try with any other number here. Let's say I'll upload 5. So as you can see, the number of entries got incremented by 1, and 5 is uploaded as well here. Can you guys do that and check it out?
I didn't get the logic. Could you say that again? Like by updating the value, what change happens?
So in the URL, right, you have the API key, that is the write API key, which allows you to write into the particular field. And then you're writing it into field 1, and what you're writing is nothing but what is there in the last, the number. You just have to change the number and enter.
Okay. What change will that make to the
You
number
have to go
display?
to your ThinkSpeak thing, and in the graph, the values will be uploaded.
All right. All right. All right.
Did you get it?
Yeah.
I'm checking 1 second. Yeah.
Yeah, so now the same thing will be doing it using the hardware, for which you guys need a few installations. I'll share that. How many of you have the ESP8266 hardware?
I have ESP32.
Yeah, you can use ESP32 for this, no problem. Only the libraries will change. So I hope everybody has the IDE installed, Arduino IDE. Can anyone answer?
Yes, and even ESP32 add-on is there.
Yeah, fine.
Hello,
Oh,
I can use Raspberry Pi Pico for this, right? Pico W.
yeah, yeah, you can use, but I'm not sure how the coding part actually works in that.
Oh, okay. Right.
Yeah. So for those who have of people who don't have the ESP8266 add-on, you have to follow these steps. Um, is anyone who's doing it right now?
Me. Yeah.
Yeah.
I have the ESP32 installed. Will that also work, or is this a different one?
32 will work. You just have to put that particular board manager there.
Okay.
Yeah.
We don't have either of the boards with us. What do we do?
I guess you can just follow along the workshop and then maybe work on that later.
Good.
Yeah.
Also, by any chance, would you be providing the link for downloading this, for installing this ESP8266?
I'll send the document. I'll send this whole document now. Uh, um,
Okay.
One second. So just open your IDE. I'll tell you what to do. I've shared the link in the chat box. So what you have to do is first go to File, then Preferences, and then you just have to copy paste the link here. The guy who asked, "Are you doing it?"
Yeah.
Could you please repeat it again? The link which you have given it, I just got a code from that, nothing else.
Oh, that thing you have to put it in your preferences part of Arduino IDE. You just don't
So
have.
now we need to install this red. Can you give the link? Can you provide us the link?
Um, you don't have Arduino IDE, is it?
No, like actually we used a different one earlier and then we don't use it anymore. So
Oh, okay, fine. Can you just download the IDE now?
yeah.
Just type out Arduino IDE download. You can just download it.
Okay, sure.
Yeah, I'll share this docs with y'all so that you can easily.
what's the objective of the project?
It is to upload the data to the ThinkSpeak fields and also read it.
Okay, the
If you,
temperature data.
yeah, temperature data. If you have any other sensor, you can use it.
All right.
Could you share the link for ESP32 if you have?
Yeah, I'll search it up. Board manager link, right?
Yes, for preferences.
Yeah. So Shan, see if this one works. The one which I've sent in the chat box.
Okay, give me 1 second.
Yeah. 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 You guys can follow that for setting up the board. If you have any doubts, please ask. Sushant, is it working?
On it 1 second.
Fine.
Yeah, it's working. Thanks.
Yeah, fine. By the time others are setting up their ID, can we go through the code or does anyone want some time?
After installing the ID, what's the next step?
After installing the IDE, you're able to open the software, right?
Yeah.
Yeah. You can follow the instructions given in the installations. Just go to File and then
Okay.
Preferences.
Okay, file.
Nitya, you're on mute.
Yeah, tell me. I got it.
Yeah.
Yeah, just give me like 2 minutes. I'm doing it.
Yeah, fine. Meanwhile, has anyone already worked on this ESP8266 and stuff for any other IoT projects and all?
No, 89.
Okay, fine.
Excuse me.
Yeah.
Dude, in preferences, what exactly should I do now?
So when you go to preferences, you can see something called additional board managers URL, right?
Yeah.
There you just have to put the URL, the first URL if you're using the 82661.
Okay. Fine.
And then okay, that's it.
Okay. Thank you.
Yeah.
So after preferences, what is it? What's the next?
Did you add the URL?
No, I haven't. Okay, the one which you've given, I need to add it, right? And
Yeah,
browse.
yeah. You can see through that installation document. I've added the screenshots as well.
Okay, I'll do it.
Yeah.
There are two URLs, namely website URL and just URL. Which one should I add?
The first one, if you are using the 8266, or the second one, if you are using the 32. In the chat box, right? You're talking about the chat
No,
box.
no. In that code thingy for the 82661,
Yeah.
there's basically in the packages first, basically there is a website URL, and
Hmm.
then this URL which contains the zip folder thing. So I should add that one.
Are you talking about the installation document?
Yeah.
There's only one link, right?
Hmm.
Oh, no, no. You're going very far. I mean, okay. Um, First, you can see file preferences, right?
Yeah.
And then next line, I've written something called enter and the link in bold.
Hmm. Where exactly?
In the first page, just below the first picture.
One sec.
Or you can just see the chat box and the first link will do good.
Okay. All right.
Yeah. Meanwhile, these people set up, I'll be sharing the codes with y'all. You guys can try executing, like to whoever has finished the setup and part.
Once we install the ESP8266 tickets, is the installation over?
Is the
Is the entire installation over? Because like the Word document says some sketch include library also.
no, that is for the later part. Once you're done installing in that window, it's done.
Okay.
Yeah, so now I'll share the codes on the chat box. Whoever has finished can try doing that. After like around 2-3 minutes, I'll explain the code so that others can also finish with the installations and part.
After typing ESP826 in the board manager, what is the next? step for that?
You'll
Like, we should just click that, and there's no yes, no, there's nothing like that.
once you type out ESP8266, you'll get something called Buy ESP8266 Community.
Yeah.
Just click on install, and then it'll install, and then you can close it. That's done.
There's no such option called install. I'll just check with it and get back to you.
Yeah, fine.
Scroll below, you might find the button. Like there'll be search bar, type ESP8266.
8266, yeah.
Could you please repeat last few instructions? We lost connectivity and we're trying
Yeah.
to.
Till where have you finished?
Yeah, in preference, we have pasted the link over there, and then after that, we
Just click on OK.
Yeah. Yeah.
And then you have to go to Tools.
Tools, okay.
And then Board.
The board, is it?
Yeah. And you'll get some option called Board Manager.
Sorry, what?
Yes.
Board Manager.
Got it.
Yeah, got it.
Yeah, click on that and just type out ESP8266. As simple as that.
Okay, thank you.
Yeah. So for those of you who have completed the installation and
Excuse me, Rashmi. You told us to type ESP8266, is it?
Yeah, ESP8266.
It does not show any results for me. Could you please tell me what problem there could be?
You're in the board manager itself, right?